Right, hi guys. In this question from day 21, um, what we've got here is the modulus of z is equal to 1. And also we're told that z is an element of c, which means complex numbers. So we're simply told z is a complex number. And this is what we're trying to prove, that the argument of 1 plus z over 1 minus z is equal to positive or negative pi over 2. So just in terms of trying to think about this question beforehand, if the argument of something is going to be pi over 2, for example, then what does that tell you about the real part? Or if the argument's negative pi over 2, once again, what would the real part be? And that's the clue to this question. Basically, if we can show that the real part, okay, doesn't exist, or is zero in other words, then we've proven that the argument is going to be pi over 2 or negative pi over 2. So I want you to pause the video at this stage, okay, and then try and work through trying to show that the real part is going to be basically 0. Okay, so pause now and then pick up basically once you've had a go. Alright, so welcome back. So working through this one here, okay, so what we're going to do is a pretty typical thing with this kind of Schol or NCA level 3 questions. I'm going to let z, let me just a moment, why is that not working for me? Okay, just a second. Alright, picking back up again here. Okay, so we're going to do the typical thing, which is let z equal x plus yi. So what I did first of all is to calculate this modulus of z. The fact that it equals 1 would mean that if I take z being this, the square root of x squared plus y squared would equal 1, which means that x squared plus y squared is equal to 1. Right, so let's get the argument of this expression here. So 1 plus z would be 1 plus x plus yi, and 1 minus z will be 1 minus x plus yi, being careful there with the bracket around that. Let's just expand this out a little bit. So that's the real part on the top line, imaginary part there. Then 1 minus x will be the real part here, and negative yi would be the imaginary part. Now I'm going to multiply by the conjugate of the bottom line, so that would be 1 minus x plus yi, and the same on the bottom line. This is a typical thing that you would at least try. I can't really see any other way of progressing with this question anyway. So let's expand this out. We're going to get 1 plus x times 1 minus x, which will give 1 minus x squared when you simplify it. So we're going to get a negative x and a positive x. That's the difference of two squares basically. Then we're going to get, so that was that times that, and we're going to get 1 plus x times yi. Let's just put that like that for now. And then plus 1 minus x times yi, and plus y squared I squared. Oops, let's undo that. Yeah. Okay, then we're going to get 1 minus x squared. This times positive yi and the same thing times negative yi, they'll cancel. So I'm not going to bother putting that down. And negative yi times positive yi will be minus y squared I squared. Okay, let's simplify. Okay, so we're going to get a positive yi, positive xyi. We're going to also get now yi positive and negative xyi. And this y squared I squared simplifies to negative y squared. Bottom line is going to be 1 minus 2x plus x squared. And this is going to become positive y squared. I'm just pausing there. No, that's correct. Yep. Okay, just moving on. So we're going to get a little bit of cancelling going on top line. Okay, so we're going to get that positive xyi and a negative xyi will cancel. Top line is going to have then 1, now minus, we've got negative x squared and negative y squared, so I'm going to factorize out negative 1 from those two. And then we've got 2 lots of yi. Bottom line, okay, this x squared plus y squared is going to become 1. So what have we got here? Well, we've got 1. Now remember, this is equal to 1. So we get 1 take away 1. So we're just left with, on the top line, 2yi. And on the bottom line, that 1 plus 1 is going to be 2. So 2 minus 2x. And you can cancel out a common factor of 2 top and bottom. So you end up with y over 1 minus xi. Now what you should see here is that the real part, let's see if I can squeeze it in down the bottom. In fact, I'm just going to put it up here. So real part equals 0. So if you plot this thing on an Argand diagram, let's just quickly do that. Where's my straight line? Where's the tools? That's the one. Let's get that. No, yellow will do. And let's go back to green. So real, imaginary. So depending on what the values of y and x are, because we're not told anything about those in particular, either this will be up here somewhere. Let's assume that y is positive and 1 minus x is positive. So that'll be one case. And the other case would be if you end up with, let's say, y being positive and 1 minus x being negative, or vice versa. Okay, then this will be down here somewhere. So in both cases, the argument will be either pi over 2 or negative pi over 2. So that's what you would need to state. I mean, you'd have to state what I just stated there in words, perhaps with the aid of a diagram, just to convince the examiner that this here will either be a complex number up here in the positive imaginary direction, or the negative. So once again, positive if the top and bottom line are both positive, or both negative. And the other situation would be if y is, say, positive and 1 minus x is negative, or vice versa, where y is negative, or did I just say that? Where y, let's say it's negative and 1 minus x is positive. Okay, so that's that question there. Right, so just going to move on to the second question for today. So I'm just going to pause the video while I just write that up. Right, so this is the second question from this day 21, so question 2. Now, as a bit of a clue for this one here, if you're not sure how to get started, then think about how if you had like the tan of an angle times the cotan of that angle. given that they are inverse functions, what you'd be left with is equal to just the angle. Alright, double check that 1 second.